Welcome to this tutorial on basic slicing in two-dimensional arrays. In this video, you'll learn how to effectively extract rows and columns from NumPy arrays. Slicing is a fundamental skill that allows you to work with specific portions of your data, making it essential for data analysis and manipulation tasks. Before we dive into slicing, let's understand what a two-dimensional array looks like. A 2D array is essentially a grid of numbers organized in rows and columns. Here we have a sample array with 3 rows and 4 columns, containing numbers from 1 to 12. Think of it like a spreadsheet where data is arranged in a table format. Each element has a specific position defined by its row and column. Let's create our sample array using NumPy. First, we import NumPy as NP, then we use the array function to create a two-dimensional array. We pass a list of lists, where each inner list represents a row. Our array has 3 rows. The first row contains 1, 2, 3, 4. The second row contains 5, 6, 7, 8. And the third row contains 9, 10, 11, 12. This array will be our working example throughout this tutorial. The syntax for slicing two-dimensional arrays uses square brackets with 2 components separated by a comma. The first component specifies which rows you want, and the second component specifies which columns you want. This is written as array name in square brackets, followed by rows, comma, columns. The rows parameter controls the first dimension, also known as axis 0. The columns parameter controls the second dimension, or axis 1. Understanding this syntax is crucial for effective array manipulation. Let's start with the simplest case, extracting a single row. To get the first row, we write a RR in square brackets, followed by 0. Remember, Python uses zero-based indexing, so the first row is at index 0. This returns a one-dimensional array containing 1, 2, 3, 4. Notice that when you select a single row, you get all the columns from that row by default. This is a quick way to extract an entire row from your two-dimensional array. Extracting a column requires a slightly different approach. To get the second column, we write a RR in square brackets, followed by a colon, comma, 1. The colon before the comma means all rows, and the one after the comma specifies column index 1, which is the second column. This returns a one-dimensional array containing 2, 6, 10. The colon is essential here because we need to specify that we want this column from all rows in the array. Now let's extract multiple rows using a range. To get the first 2 rows, we write a RR in square brackets followed by 0 colon 2. This means start at row 0 and go up to but not including row 2. So we get rows at index 0 and 1. The result is a two-dimensional array containing the first 2 rows, 1, 2, 3, 4 in the first row, and 5, 6, 7, 8 in the second row. When you don't specify columns, all columns are included by default. Finally, let's extract a specific rectangular portion of the array. To get rows 1 through 2 and columns 1 through 3, we write a RR in square brackets, followed by 1 colon 3, comma, 1 colon 4. The first part, 1 colon 3, selects rows at index 1 and 2. The second part, 1 colon 4, selects columns at index 1, 2, and 3. This creates a subarray with 2 rows and 3 columns, containing 6, 7, 8 in the first row, and 10, 11, 12 in the second row. This technique is incredibly useful when you need to work with a specific section of your data.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.